Hello, everyone. Welcome to 2024 and a new episode of the Day Zero podcast. And just a note, going forward, for now at least, the podcast will be distributed as VOD only. We're not doing the podcast live. Z may do some prep streams and getting the topics together live, but both of us discussing the topics will be recorded. And that's just to give us some more flexibility and allow cleaning up the podcast a bit, do some editing, etc.
Yeah, hopefully
So,
have, some higher quality editing coming out of it. Maybe less rambling and we can get more to the point or something like that. But, hopefully we'll get some nice benefits from it.
yeah. But also, it's just a lot nicer for us, too. Because sometimes we have the technical difficulties and then we're delaying doing the stream and it can get annoying sometimes and we won't have to deal with those types of problems anymore.
Being able to fully prepare. I mean, there have been times I've come into episodes where it's like, I've read the topic, I'm roughly ready to go, but I'd like a few more minutes. Not having the same pressure and just being able to kind of take our time to prepare a little bit more and get some of those last minute things in will also be, I think, a nice benefit for us.
Definitely. So, yeah, we hope everyone had a fun winter holiday or Christmas or whatever you're celebrating. It was not so fun for me. So it turns out some of you who listened to the last podcast we had before we went on break, you will have noticed that our binary episode wasn't streamed until Thursday instead of Tuesday. And that was because I was sick. And it turned out that was COVID. So all the family stuff was completely canceled. So that was awesome. And it racked me for a little while. So I'm doing better now, but it really threw off Christmas plans, unfortunately. I was able to eventually do stuff around New Year's. I went to the local card store and tried playing some card games, which before I'd only played on the computer, and I felt pretty stupid because it's really hard playing complicated card games in real life. Card games in this context being Yu-Gi-Oh! But
Yeah, when you said
yeah, that
card
was pretty
store,
much.
I kind of imagine not playing
You thought
cards.
greeting cards?
I thought greeting cards. Yeah,
Yeah, no.
exactly that. When
Yeah,
you
sorry.
said
Should have
games,
been
I
more
got it.
specific. Yeah.
Yeah, when you said games, I totally got what you meant, but at first, like my image was like you went, card shopping. Yeah, and I
That's a fair
mean,
interpretation, especially with the time frame. Yeah.
yeah. And I'm just going to blame you. Like that last podcast episode, it definitely got me sick since I got sick shortly after Christmas and was kind of out for a bit too. So I'll just put the blame on you
Yep.
spreading COVID to me, despite the fact that it definitely wasn't COVID. You can take the blame for that one.
All right. Well, I will accept it. But yeah, so that was pretty much my holidays. I didn't really get to do too much, but I did get to see some people eventually, around New Year's or so, and like I said, tried playing some Yu-Gi-Oh in real life. That was kind of fun, but keeping track of states and stuff in your head is really difficult, and I already tried to do that for security, so it's a little too exhausting. I don't know if I'll be playing the game too much in real life, but it was a fun experience. So
Yeah,
how
I
about
mean,
you? What did you
definitely.
do?
I mean, that definitely sounds like a bit of a different experience. I don't really play
Yeah.
any card games, but back when I was a kid, Pokemon was really popular, and I tried playing Pokemon online at one point. And having the machine kind of tracking the state. I mean, we actually just played over IRC, so it wasn't like anything too fancy, but it was you had the history to reference. So definitely a lot
Yeah.
nicer playing that way than trying to do it all in person. Not that I really ever fully even understood all the rules on even a game like that. I mean, I was like 9 years old. I wasn't too far into it, but yeah, I mean, my New Year's, my Christmas was with family, kind of usual thing there, and my New Year's I tend to spend. I volunteer and help set up like all the tech stuff for a event that runs kind of locally here. I guess locally in relative terms, still like nearly a 3 hour drive for me, but they do kind of like a big chem-free New Year's party for the teens in the area. So I help deal with some of the tech for that and kind of keep things running. So we'll usually do some like gaming tournaments during that night, among other things are going on too. But my realm involves kind of running a lot of computer systems and like the arcade systems going on there.
Part of the infrastructure. Yeah. definitely a lot more productive than I am over the holidays. So.
Yeah, well, it
Uh,
gives me something to do over the holidays too. It's
yeah.
because the way I got involved with that was it was really just old friend of mine. We had met, and then of course I moved off to. That was right before I moved to the UK. So when I'd come back for Christmas, it's like he was working there. He's actually part of like their staff. So it's just like I would volunteer to do that, so we would then have some time to hang out.
But yeah, one of the things that happened over the holidays that because of like the the sickness and all the stuff that was going on was CCC. It did happen this year, thankfully. It almost seemed like up until it did happen, it wasn't even sure that it was going to happen. The tickets sales went up so late. I don't think the ticket sales went up until like end of November, early December. So because of that reason, I didn't end up going. Turned out to kind of work for the best because all things being equal, I would have been screwed because I got hit with COVID like the day I would have been leaving for Germany. So it sucked that I wasn't able to meet up with people there that, especially like a lot of the Europeans that I talked to online. It's a great event for meeting up with them because DEF CON is quite a long flight for them. So a fair amount of them don't make it to DEF CON. So it allows me to meet up with more people, but that just didn't end up happening this year. That said, I did speak to a number of people that went, and it sounded like it was a really cool event. Sounds like things went smoothly. There was a lot of really cool talks. I haven't checked them out yet, so I don't have any recommendations to give in this like episode. But next week, I'm hoping to give out some recommendations after I do some catch up on some of the talks. But just from people that I know who went there and glancing at some of the talks that were given, there were like two or three that were really highly praised and talked about. Like there was one on packing trains. There was another one on an iPhone exploit chain. And yeah, I mean, as always, usually CCC has a lot of good talks, but this year in particular seems to be kind of making up for the last few years of not having the conference because there was some crazy stuff. So
Yeah, I definitely
we do want to bring that up on the podcast at some point.
Yeah, I definitely heard about at least a few CCC talks, though. Like you, I haven't actually checked any out yet. Just the timing of the conference kind of sucks for me. And speaking about being
In
close,
general,
actually, yeah, like just in general, like I said, I do this volunteer work for the New Year's event, and that's exactly when CCC runs. So kind of a choice between them. But one of our topics today actually does have a CCC talk that I haven't yet watched. But when you're speaking about being close, they talk about in that post, they got the news that they would be talking at CCC on December 3rd. And whereas the conference was like later that month, so like literally just a few weeks ahead of it, speakers were being told their talk was accepted or not.
that's pretty
That's
insane.
pretty tight, yeah. Like
Yeah,
especially for a
hopefully in
con,
future
like
years, especially where like yeah, you're going like to Europe and whatever, like for North Americans especially, that's pretty brutal. And that's a big reason why I didn't go is by the time I would have been able to be sure I could get a ticket, the flight and hotel costs would have been absolutely absurd because of how late it was. I'm hoping in future years it goes back sort of to where it was before. I mean, CCC's always been a little bit late, or at least the last couple years that I've been paying attention to it, it's been pretty late, like October or so. But this year was especially late, so hopefully in future years, now that it has come back, it's more smooth. But
yeah,
yeah,
I think
it was tricky for a lot of people this year. There was a few people I know that typically go that didn't this year because of how late things were.
yeah, I think it was especially challenging with this year being the first I think it's the first year back in person. So
Since
like it
2019, yep.
yeah, and in past years, like the last time I went in like mid 2010s, you knew what was happening. It was going to happen during that period. There wasn't that extra question, so like you could still get a flight ahead of time. I mean, you do have the ticket rush, which is a bit of a risk, but you weren't questioning if it was even going to happen or not, like you were even with CCC. And then, yeah, tickets being so late meant you had that additional kind of pressure on it.
Part of the problem too was this year they'd moved from Leipzig to
That too.
Hamburg, and it was a smaller venue, so it was also even more up in the air as to whether or not you'd be able to secure a ticket. So, especially if you didn't have connections with people. But The really cool thing with CCC is that even if you unfortunately don't get to go in person, the talks are up immediately, which is not the case with many conferences. So that's why we're able to get some of the stuff that we're going to be talking about today and tomorrow. Whereas with some other conferences, it'd probably be some weeks or some months before that information would come out. So that's a bit of a consolation prize, you know. With that said, I guess we can get into some of our topics. Starting off a little bit light, we have a post from Microsoft's Browser Vulnerability Research Lab on some issues that get reported to their bounty program that aren't eligible for rewards, and specifically for the first blog post, local attacks on the client from physical access or other software on the device.
Yeah, like
And
local
while,
user attacks. So
yeah,
things that are your user account. But sorry, go ahead.
so while they're primarily focused on threats that come remotely from the web, they do try to protect against local attacks as well, Microsoft that is, but there's trade-offs that don't always make sense to make. So getting into some of the submissions they wanted to talk about and some examples. Up first, they have, when I open the database of stored credentials, I can see the stored credentials, which they say gets reported a lot. And this is talking about the fact that where browsers have built-in password managers nowadays and will store or save passwords in a local SQLite database and app data, obviously those credentials being stored there, if an attacker can get access to them, it can be a problem. And particularly when the process is running, those credentials may look like they're stored in plain text or something. But as they see here, they do take steps to protect this data. The SQLite database is encrypted with AES and goes through Chromium's OS crypt, which is backed by the Windows Data Protection API. But of course, there are ways around this with sufficient access. For example, they note that with medium integrity level on Windows, you can simply just edit and hijack the process of Edge in order to siphon the credentials. And that's just a recognized thing that an attacker with sufficient privileges on a target device can do things like this, and there's not a ton you can really do to stop it without just stripping the functionality entirely. So that's
And
kind of the types of issues that they're trying to get at with this post and address.
with this, with the passwords, it appears to be unencrypted because if you like go navigate to whatever folder this is stored in, you go navigate there and like your Windows Explorer, you open the file and you see, hey, this is unencrypted data, and it looks bad. The problem is like the OS crypt that's mentioned does kind of like transparent encryption. So like this is tied to your Windows user account, and when you log in, then you get access to the data that your Windows user account, has the access to. Or at least I believe it's tied to the Windows login. Reading about OS crypt, it talks about tying it to the login. So I'm presuming, because they are using like the Windows API and stuff, that this is tied to your Windows login, but I guess it could be tied to a Chrome login too. Just didn't seem that way when I was reading the documentation. But because it's transparent, like I do get somebody kind of navigating in there and thinking, oh, this isn't encrypted. Whereas in reality, it is, it's just done in a transparent way. So because it's unlocked to your user and you have the credentials like at the point where you're navigating to it doesn't appear to be locked. So I kind of get like that sort of mistake happening if that is how this works. I didn't dig too deeply into how OS crypt works, but like I get the concern there, but because it is like a local attack, a user has access to the credentials because they are the user. It's the threat model isn't there for this sort of attack. And then as they get into like if you're already running codes as the same user, there's a lot of things that could be done to get access to the data regardless, because the process needs to be able to decrypt it. So other code would be able to have access to it as they showed out with just injecting other code.
Which they also transition into talking about with things like malicious DLLs. So they talk about like if I place a malicious DLL in Edge's application install path, I can run arbitrary code in Edge. And again, this is another case where if an attacker can place arbitrary DLLs inside of Edge's installation directory with admin capabilities, there's not much that can really be done at that point. And I think something you had said there is like a perfect summation of this post and the types of issues that they're talking about is that idea of threat model. It's easy to just like try to look for problems and report them as problems without considering the threat model, but you have to consider the threat model. Like that's an important part of it that sometimes gets missed in some of these reports, I think. Or
Actually,
just the nuances aren't recognized that are important for the threat model that's in question.
I think it's especially common when we're talking about desktop applications because it is a bit of a weird scenario to be in, because a lot of times when we're looking at vulnerabilities, we're talking about these bugs, it's like the web, where if you can do something that like leaks sensitive data, gets access to it, like it is a vulnerability because you're not supposed to get that in the first place. Whereas as a user, as like the local user on a machine, you have a pretty privileged bit of access already, and you can do a lot that just an application cannot reasonably defend itself. Like, unless you're getting into like all the anti-cheating, like stuff that goes on in like game hacking and that kind of realm of work, like there are things you can do, but generally just a cat and mouse. Like you can't ultimately stop a lot of it. You can just make it more difficult. So, like with this one, just being aware of kind of the threat model that you as a local attacker can already do a lot of things. So, a lot of things just aren't going to be necessarily considered vulnerable, and being aware of, now you're a local user for like some to be a vulnerability, you generally need to cross some sort of privilege boundary. You need some escalation of your privileges. You need to do something you shouldn't be able to do. If you're able to place, in this example there, if you're able to write a DLL into an administrator writable directory, you're getting code execution as a user. That is actually a step down in privileges, not a step up. Like it is executing code, but you're not actually getting a new privilege, or you're not actually stepping up in any way. It's technically kind of a step down because Edge is going to run with a lower integrity level and lower privileges. The third one honestly feels like exactly the same issue. If I run a program to inject a DLL into Edge, you can read and modify and do all that. Basically the same thing. You need to have that level of access already to do that. And you're just like, going from user to user access.
Yeah, a lot of the issues they're talking about here are just things that could potentially be issues and maybe should be worked on to be mitigated, but are ultimately, they have nuances that aren't being considered for the threat model. So I think it is a good post just to talk about, like, just to highlight the importance of threat modeling and keeping in mind like all the nuances before just blindly reporting issues. And it can be frustrating. Like I can imagine how annoying it must be for like MSRC and other bounty program maintainers to sort through all these kinds of reports that they see all the time and just have to repeat over and over their statements about, won't fix, so to speak. So I think this is a cool post to put out there. It's not highly technical compared to some of the other Microsoft browser research posts we put out there, but I think it is still something that's important to talk about.
Yeah, I mean, compared to what they usually put out, this isn't all that technical, but I thought it was an interesting insight into like the fact that, yeah, they are getting these. Like, I'm not surprised that they're getting these sorts of reports in. It's very kind of fitting for, if you've ever looked at like the HackerOne of a lot of desktop applications, if they actually disclose, you'll see a lot of these simple things where it's like DLL injection from like, the user, or like writing admin files. You see these same things. So these are common just among desktop applications, along with being able to reading sort of sensitive information. So it's not surprising to me that it's there, but it is also kind of nice to see them talking about it and actually calling them out too.
Kind of a
Yeah.
call to action. Yeah.
Yeah, I think the big thing though is just be aware of your threat model, what you're actually able to accomplish with this that you couldn't otherwise have done, like the DLL injection, because you can only inject processes that are of the same integrity level or lower, and that belong to your user. Like you're not really getting anything you couldn't already get through a number of other ways. Like there's no attack there, so taking the time to understand the threats that are actually facing it. I was hoping to actually find like a good resource about auditing desktop applications, and I honestly couldn't find any. So if somebody does know something good, I'd appreciate it. Like I'd love to see something that's kind of modern about doing that. Because I mean, like Art of Software Security Assessment does technically talk about it and does cover it to a degree, but it's not really what I would recommend in the modern day, given how old that book is. Because that section, it is also talking about a lot of like, the Windows, what was that in 2007, like, Windows XP era, I guess. um
XP, Vista, yeah.
Yeah, like kind of talking that era. Like things have definitely changed in terms of some of the permission models and stuff. So like I don't think UAC existed yet, although that isn't technically a permission boundary. Still, like
That's a whole
point
nother
being,
can of worms.
yeah, my point being like there are some special concerns when it comes to these desktop applications and doing those audits that do make it a kind of unique area. And I haven't seen a lot talking about like how to do a good audit of them. Closest thing I was able to find was I did come across, the OWASP desktop app security top 10. I'm going to be honest, I'm not a big fan of this list. Like, I'm not a big fan of how OWASP top 10 has gone in general with these very, very generic injections as being like their number one. I'm just not a fan, but it is a starting place for some sort of things when it comes to like improper authorization and looking at folder permissions and some of those aspects, but that's kind of the best I found. I'm sure there's something better out there. So if you guys know it, feel free to share it in our Discord or something, because I'd love to see any recommendations on that front. 'Cause I genuinely have none. Just experience, really.
It'd be nice to have something to have on hand, yeah.
Yeah.
But like you said, desktop security is a little bit tricky, and especially because you have more of the you're tied more to the OS, like you have more of those OS specific nuances. That also makes it more challenging. Your permission models on Linux compared to Mac OS compared to Windows, like all those are going to be pretty different, and you have to, especially if you're trying to write a report, you should probably have a solid grasp of whatever platform you're trying to report for. So it can be a bit tricky, and yeah, a nice resource like that would be welcome.
Yeah, there are differences, but there are overlaps. So, like,
Yeah, I'm not trying to say it's a completely different world or anything, but there are, it's been like the devil is in the details, which is something they kind of highlight in this post, right?
yeah.
And in order to get those details right, you're going to have to be familiar with the specifics of the platform. So,
Yeah, fair.
all right, so getting into our next post, we have a Medium post on the power of client-side path traversal. So that's a favorite of ours to talk about. We like the client-side stuff, and I'll let Z get into it.
Yeah, well, since this came out, I feel like it was maybe a year, maybe 2 years ago when we first covered like something about client-side path traversal. And to me, it was just like a novelty. It was something that like I hadn't really thought about this sort of attack. Of course, we know about path traversals in general for like file uploads or file disclosures and stuff. Really common, really well understood. And applying that onto like JavaScript when it's going to fetch a page and doing the traversal there just wasn't even a thought that really crossed my mind. So it was a novelty to me. And since then, we've seen, I think this is maybe our second or third time kind of talking about somebody who's found an issue that they were able to exploit because of this sort of client side traversal. And so coming down, first issue that they kind of talk about in here. So the actual program that they were hacking on was a private program. They mentioned that this was some tool that they would have used a lot when they were in high school. So they just refer to as redacted.com. And so as I go through this, redacted.com is what they were working on, but that's not the real website, of course. First thing that they kind of came across, or really they're just giving an example case here actually, is just they had, for example, this redacted.com slash example slash followed by like a random looking UUID. And then on that page, you loaded it, and JavaScript would then read that UUID out and make its own call to this resources.redacted.com slash resources with that same UUID. So it would take that UUID from the URL, parse it into, or parse out the UUID, and then use it in another request. So what if you put some URL encoded slashes in there? What they were able to get was that JavaScript would take the URL, it would URL decode those slashes, and when it would resolve the URL that's supposed to actually access, you would be able to get a path traversal in there. So they use the example here of going resources, blah, and then dot slash, some other resource or some other directory. Basically, they can just point it to a new location. That's your classic client-side traversal attack, is just being able to push it to other locations. So the first place where they found where this was actually a bug is with the accept invitation page. In that, it would take a few URL parameters, including the user ID, name, and an invitation ID. The user ID and invitation IDs for both these UIDs, and the one that matters here is that invitation ID. When you access this page to accept an invite for whatever, it would have a nice big button there saying like accept invitation. You would click that button and it would send a post request to redacted.com/invite/ whatever that UUID was, and then /accept. So what if you could put the encoded slash in there and do this path traversal? Now you can actually change the place where it's making this post request to from redact.com/invite/ and you can put it to any endpoint that you know about, and it's going to make a legitimate post request to it from the same website by doing like .. some action. You would change that endpoint, and that's what they found they could do. They could, for example, have a post to /logout and log the user out. Logout CSRF, always a very fun attack. Also often just rejected by bounty programs. But they could also say send it to a course. Then if you had the course ID, you can publish, or you could share a course with a specific user ID, or even calling it out to delete. This would depend on those post requests not requiring a specific post body format, so some specific data in the post body. Seems like that is the case here because it is passing the IDs and actually specifying the action it wants in the URL by being like /publish, /share and stuff. It seems like the body either could be empty or could contain whatever. As long as it makes a post request to those endpoints, it's going to perform that action. So using this accept invite, by doing that client-side path traversal, they push it, or they traverse to a different endpoint, so it does one of these other actions, makes a legitimate post request. Because keep in mind, since this is originating from that same website, same site cookies, they're all going to be sent because you're on the same site. They do call this CSRF, but I guess this would perhaps more accurately be called an on-site request forgery, though I don't see that used super often, since you're forging the request from the same website. Same site or on-site request forgery, I think, would be a bit more common, but the concept's the same as a CSRF. You're just causing this illegitimate request to be crafted and sent over. I mean, a lot of applications will do that, so it is something to keep in mind if you're looking for a way to escalate some of these issues. Some applications are written in a way that they want all the data to be sent in that post body. But especially when I've seen a number of like RESTful APIs, they'll tend to do this where they'll include a lot of information in the URL, and the verb of the like a post is just telling you what it's supposed to do with that, and it doesn't actually use the post body too much. So those are where this sort of attack could be quite powerful, as they found here. And one of the other ways they found to abuse this was in taking a self XSS and turning it into a stored XSS they could actually share around. So that came from a couple things. Long story short, you have this functionality, the story creator functionality, where you can like create a collage of images, video, and text. And the way that would work is it would just store like an array of JSON blobs, where it would just contain like this is an image, and then the URL of the image is a video, URL of the video. Just stores these simple blobs of type and URL for whatever it is. And when you access this as like a draft, it would have this create URL followed by the UUID for it. And it would do the whole JavaScript fetch to go get the draft and use that UUID again in that. So you have that traversal again, but the XSS itself just comes down to if you change the type to an iframe, you can give it a URL, and that could include a JavaScript in it. However, the iframe type was basically only rendered if you're in a draft. So if this was a published document or a published story, I guess, trying to access it, it just wouldn't render the iframe, so you could only do the iframes against yourself. No idea why that's their functionality. It seemed like the iframe actually wasn't even like officially supported. It's just noted in one of their errors where if you use this unexpected type, it mentions that it's expecting the type to be like video, image, text, or iframe. So kind of exposed it that way, only works in drafts. So they use the client-side traversal to take a draft URL, and use the traversal to point this UUID to make it load a published URL. And the published URL is basically just a different endpoint. So on your draft, if you're accessing through the draft, it's going to try and access the stories/draft/ whatever the ID is. And then it'll get the JSON blob from there. And if it's a draft, like, it's only going to be accessible by that specific user. This isn't like an IDOR sort of issue. But if it is published and you're accessing it through that published page, it's going to go to stories/ID/public. So you use this, use the client-side traversal in the ID, gain that UUID traverse. So you go back one directory, give it the ID again, and make it act like the /public, basically translating the URL. And you can access one of these published ones that can be reached by any user, the same JSON blob, from the draft page example. So basically escalating their self-access. It seems to only be usable from the one page where the attacker would be attacking themselves, and making it accessible or accessing it from, or getting it access from any page, basically. Honestly, kind of cool attacks. Nice to kind of see this really simple core bug of client-side traversal being abused more. I'm kind of excited to see people doing these write-ups, because it is, I think, an interesting bug class that at least I've personally overlooked and just haven't really thought about even using in my chains, but it's pretty nice to see and good find.
Yeah, the self XSS to stored XSS idea was pretty cool. I hadn't checked out that section too much in this post, but yeah, it's a cool way of abusing it.
Yeah, like, I like the first part more personally. I like that, just being able to craft the post request and then make all like the things that are generally supposed to be protected by CSRF. And usually with this sort of attack, because you're generating a legitimate request, if there were even a CSRF token in play, if that had to be included on all the posts or something, odds are this thing making the post for the accept invite would include that for you. So it's one of those issues. I really like it for the fact that it's using kind of some of the code against it, or using the code against itself in a sense. I don't know. It's something that warms my heart to see.
Fair enough. All right, so up next we have a Talos vulnerability report on Instapod's DuoUniversalKeycloakAuthenticator plugin, which is used for Keycloak, which is an open source Java-based IAM provider. And I'll let Z get into this one as well.
Yeah, and this one, really simple issue. It's more, actually, I wanted to call this out less because of like this specific issue being like really critical, or you're going to find the exact thing elsewhere. I guess you might, but just the style of issue I think is really important to keep in mind. And what's going on here is effectively you've got Keycloak, somebody's going to try and log in on there, and they have this DuoUniversalKeycloakAuthenticator plugin that will, once you authenticate properly, it's then going to redirect you over to the configured Duo security endpoint. So you then end up going through like the Duo multi-factor authentication flow. So that makes sense, but when it does that redirect, so this is your login, so you've sent your credentials in this request, you send your credentials there, and then it's going to be like, okay, you passed that, now let's redirect you over to Duo. And it does that redirect using this response.temporary redirect, which is equivalent to an HTTP 307 redirect. So you might be familiar, like 301 is your permanent redirect, 302, and like the 300. I think all the 300s are redirects. What's important with 307 is that it is body preserving. So if you send a post request, it is going to redirect you, and that new URL that you're giving it as a redirect, it is going to, if you made a post request, it is going to make that same post request to the new URL. So it's going to copy that same body, is going to go to the new URL. I mostly use this more as like a trampoline of sorts, where you want to redirect a post request from like a victim website. You're able to get it to go to your attacker site. You give it a 307, so it redirects back to like the actual endpoint you wanted to send that data to. Kind of in line with some types of CSRF attacks. That's mostly where I've used the 307, but this is kind of this is it being used in a sense, legitimately. But the problem is that's your authentication. Like, that is your login and your credentials to log in on the initial application that is being sent now to Duo. Now, I don't expect Duo's actually listening and noticing that, hey, all these users are sending us their credentials, but it is third-party information disclosure. And seeing that through some redirect, like, is just something to keep an eye out for it possibly being able to send information that really shouldn't. Because all they really needed here was for it to make a GET request. They just need to redirect it normally over to whatever the actual, like the Duo endpoint. Like, they didn't need it to send a post request. They just happened to be doing that kind of accidentally. And so if you were monitoring the traffic, that would really be some just to keep an eye out for, are those redirects. Because yeah, 307 should just stand out as like, why are they doing that? And is it necessary? Or it could be this sort of third party disclosure. Again, in this case, I doubt Duo was actually listening for it or doing anything malicious with that. But in some cases, it can be going somewhere that is less trustworthy, we'll say. Or it could even be attack controlled where it goes.
Yeah, those are the cases to be more wary of. But at its core, like this issue is pretty simple, but it is kind of interesting to talk about just in the way that it's something to look out for, being aware of the implications of which redirect you're using. Like, I think it would be a fair assumption that a lot of people probably wouldn't be aware that 307 redirect would send the full post body. I think we might have talked about a similar issue once or twice on the podcast before, but it doesn't come up super often.
Yeah, it's
Um,
definitely come up because it is one of those pet issues of mine that I do like kind of being able to talk about like that. It's a fun aspect of just redirects that, like 307 I've brought up at least once or twice before, but yeah, not super often. And I did just pull up the HTTP status code just to double check there. And yeah, 301 being your permanent redirect, 302 being your resource change, or just your 302 found basically. But yeah, and then 307 and 308 I believe are both going to be body preserving. 307 is temporary, 308 is the permanent version.
But yeah, it's a bit of a gotcha, and most people aren't reading like the HTTP spec or memorizing the nuances of it, so it's a fair issue to like keep an eye out for and can very easily be missed.
Oh
So
yeah, as a developer, like if you're thinking about this and writing this code, what you're doing is you're saying like you want a response to a temporary redirect to this new URI. That sounds like exactly what you want. Like,
yeah,
you do not know, like, as most web devs aren't going to know, like, oh, that's going to give me an HTTP 307, and what I actually want is like response.found, because found is giving me the 302 redirect. From the developer point of view, like, this is just bad naming. And to be fair though, like, temporary redirect is the actual status code name for 307, so it's not actually like bad naming on their part. Like, that's what it should be called, but it doesn't make sense in my mind, so it's bad naming.
fair enough. So yeah, we also do have an NCC group post in this episode, so we'll get into that here. NCC group put out a bunch of vulnerabilities in PandoraFMS, which is a remote management and monitoring app. They document 18 issues in here, so we'll only cover a couple that we found the most interesting, as that's a lot of vulnerabilities. And they range from XSS to unauthenticated admin account takeover to RCE. So a fair number of the more interesting issues are stacked towards the earlier numbers. So the first one I figured that I would call out is their unauthenticated admin account takeover via cron log file backups. And this one's just taking advantage of the fact that they will. Sorry, I almost tried clicking the CVE there, but their CVE link goes to the actual MITRE page instead of jumping to the point in the blog post. I wish that was different. But yeah, so this is just abusing the fact that they have the cron logs, and those will be rotated, and they'll compress the log file into a gzip archive and then store it with the cron.log.databackup.gzip. And in the htaccess, they try to prevent access of that cron log file. The problem is you can still access those backup files. So by just doing like a very straightforward brute force of the date of backups and knowing the directory of where the backups are stored, you can download these backups and potentially retrieve sensitive details from the log file, including the administrator session ID at the time that the cron log was written. So that's where the unauthenticated admin account takeover comes into play. When you have admin access, remote code execution via the MIBS file uploader vulnerability is relevant. So this is based on the fact that Pandora allows admins to upload SNMP MIBS files through this SNMP console operation, and these files are persisted inside of this attachments MIBS directory, and you can upload like PHP files and just upload a web shell and get RCE. It's pretty straightforward there. Another issue that I wanted to call out was another unauthenticated admin account takeover. This was through malicious agent though and XSS, which I thought was pretty interesting. What happened here was periodically agents connecting to the server will send an XML payload that identifies their agent, and admins can view these agents in the agent details page. The problem is, it seems that one of the fields in that page, being the custom ID field, is vulnerable to stored XSS and can contain attacker-controlled data, which can allow an unauthorized user through a malicious agent payload to XSS an admin to get their session ID, and again, just like the first bug, take over an admin account. The final issue I wanted to call out was an arbitrary file read as root through the GoTTY page, and this is sort of similar to something we talked about in the last bounty episode. Here, PandoraFMS console deploys the web service GoTTY on port 8081, which is a full and unrestricted SSH client, and you can just pass like URL arguments into it that are passed directly as command line arguments to the SSH client when it starts. And one of the arguments that's pretty sensitive is the -f argument or config file. And just supplying this argument along with the file path will cause SSH to attempt to read that file. And upon failing to read and parse configuration data from that file, will print the contents of the file to the user. And because GoTTY runs as root, that gives you an arbitrary file read as root. So those were the issues that I found interesting. Like I said, there are a lot of them, though. There are 18 issues in this post. A fair amount of them are stored cross-site scripting. It seems like that's the most, like, there's just a lot of XSS issues in there. There was also a few other vulnerabilities that were based from the GoTTY page. There was a DOS and also a Linux LPE. So, yeah, there's a lot more in this blog post that you can check out. And it's very easily parsable. You can go to the section. They're very brief and to the point, so you can pretty easily understand the issues. But yeah, it's just an amalgamation of a bunch of issues in PandoraFMS, and beyond the ones that I've already talked about, you can feel free to check out the blog post for the other ones, because I think we'll be here for a while if I try to go through all of them.
Yeah, there's definitely a lot in there. The GoTTY one you're just talking about with the file read, that's kind of an example of one of those cases where it's just, in a sense, it comes down to just an overly verbose error message, where it's saying that error message, and rather than just giving some generic user-friendly error, try to provide all the information a developer would want or need to fix the bug. Which is fair in some situations, but I think like a good habit to have in like developing code is to have a practice of not exposing the root error, like log the errors, log all the information you can about the errors. But when displaying in the UI, as much as it sucks as like a power user to not get full error information, it's so easy like when you try and do these overly useful error messages, it's so easy for things to accidentally slip through. Like this becoming just an arbitrary file read is, a pretty useful primitive, especially as root. Getting access to Etsy Shadow is a pretty nice primitive to have. So, and it would have been fixed had they just given had they just given the error message unable to parse config file and the name of the file it was trying to read, and then maybe logged internally like what happened, like this line wasn't a valid config line or something. It would have been resolvable by somebody with access to the logs, but the user would not have gotten the entire file. It's just one of those patterns that I have seen a ton. And while oftentimes you don't see a very clear path to exploiting it, it is one of those code smells in code when you see them dumping extra information into the errors.
It's something that should be very easily mitigated, but just isn't in the context of web, because debugging is annoying, and it's easier to just put everything in the front end, like you were saying.
Yeah, like for a developer, it's great because it's like, oh, I know exactly what that error is. Like, here's exactly what's wrong. My config file's wrong. Like, it's telling you exactly what it is there. It's just that's useful for debugging, which means it's going to be useful for an attacker too.
All right, so getting into our last post of the episode, we have a post by SecConsult, and it's on SMTP smuggling. So this was the topic that at the top of the episode, Z was saying there was a CCC talk for. Full disclosure, I haven't checked out this talk yet. I do plan to, but I just haven't gotten around to it by the time of recording. But this blog post goes into all of the details as well, and might be a little bit easier to understand if you don't want to go through like the audio and everything, as they have a fair amount of helpful diagrams in here explaining what's going on, and I'll let you get into it.
Yeah, and there was also a little bit of drama around the disclosure, which I'll try and remember to actually get to after I describe what the issue is. But they do start the post off with talking about responsible disclosure and stuff, so I'll mention that at the start here. But yeah, SMTP smuggling. Similar in concept to request smuggling. With HTTP request smuggling, the idea of at least the original type, not something newer stuff that's come out like the client desync thing. With that was you have two servers, you have your front and your back end server, they parse the same HTTP request as different things. So in theory, you have your front end passes in the request, it thinks it's all one request. Back end treats it as two different requests, and you smuggled one in there. Kind of same deal going on with SMTP. So SMTP is simple mail transfer protocol. It's another line-based system, although it's different from HTTP. Kind of came out of the same era of time, so you'll see some similarities in that is like line-based. Although what's important for SMTP is it does have a data separator, which is supposed to be a carriage return, a new line, dot, carriage return, new line. Kind of that last sequence there. I've tried to highlight it on screen, but in theory the data is going to be split like that. But you have these SMTPs, so you have the command come in as like extended hello, mail, receipt, to and from, like the to and from information. You have this top part there is your SMTP data, or your SMTP commands, all lines separated. Then when it's actually going to send the message data itself, which contains like your from, your to, subject, your actual email message again, line separated, but that data starts with a data block there and then ends with carriage return new line dot carriage return new line. So HTTP, you kind of have the headers end with just a blank line, or carriage return new line, carriage return new line. This very close, but it has a dot in there in between, and it's not separating headers, so like there are differences, but it's a simple line based protocol. And with SMTP, you have your outbound server. So when let's say you're using like Outlook or Thunderbird or some sort of desktop email client, it's going to connect to an outbound SMTP server. It's going to connect to it, perhaps do some authentication with it, say like I'm this user wanting to send this mail like as this email or something. It's just going to connect to this SMTP server, and it's going to send, do this whole hello process. It's going to go through this thing. It's going to decide like, okay, you are authorized to send the email, so let's send this email. At which point, the outbound SMTP server is going to connect to an inbound SMTP server, which is the mail server for whoever your destination is. So if you're sending it to an Outlook user, it's going to connect like Outlook's inbound SMTP server, and it's going to have a kind of similar thing coming in where it's saying, hello Outlook, here's mail from, mail to, whatever, and it's going to give the data blob again, that same data blob from before. It's going to pass that on to the inbound. So you do have the two servers going on again. You have like your outbound server, which receives the input from your mail client, and then you have the inbound server, which is actually handling like your inbound email. So you have these multiple servers. So what happens if they have a parsing disagreement on what the data is in a message? And that's where you start getting the smuggling coming in, where what they found specifically was that some servers would, some of these outbound servers would allow you to just send a new line, a dot, and then carriage return new line. So not including that very first carriage return. They would like you include that inside of one of your messages. And the outbound server would just take that and treat it as like legitimate, because technically it's not the normal end of data sequence. It's not that. So you include this slightly off end of data sequence, and then some inbound servers they found or that it would see that sequence missing that first carriage return, but having the line feed dot carriage return line feed, it would see that and be like, oh, this must be the end of the data. And therefore, whatever comes after it is now more SMTP commands, assuming it supported SMTP pipelining, which they basically talk about as that's a non-issue and everything supports it. So presumably very well supported. And pipelining just means like you don't need to open a new connection to do a new message. You could just keep sending them down the same connection. And so what they did here, this example here, is they have their one message, which includes the carriage return dot, new line dot carriage return new line. And here in the middle, the outbound server reads that, and the inbound server parses that as two different messages. Importantly, that second message now has completely controllable to and from. So they can say this is from any email, and it's just going to accept that as being somewhat legitimate. Now, there are kind of the case of like SPF, DKIM, and DMARC that kind of need to be considered here, but because you're smuggling this in with a proper outbound, I'm going to say outbound request, I guess. I'm not sure what you really want to call that, but you've got your mail server that you're sending mail like authoritatively through this outbound server. Because this is coming from a legitimate outbound server, the SPF, so SPF basically just says these IPs are allowed to send mail on behalf of my domain. And so the inbound server does these checks for like, is this the right IP? Or is this signed? So DKIM includes keys or some signing key information. And then DMARC is like your policy for, if this doesn't pass, do you quarantine it? Do you drop it? Whatever. Do you report it? Whatever. There's a bunch of things that can go in there. But what's kind of important, I believe, is that with DMARC, basically your DMARC's going to pass as long as either SPF or DKIM passes. You only need one of them to pass. And so because these are actually being sent from the authoritative actual outbound servers that have this original message, and it's just some of the inbound servers that are parsing them incorrectly, they're going to look legitimate. They're not going to trip SPF. They may trip DKIM because you can't really spoof. Like, you don't have access to the key to actually sign these messages. And the signatures are going to be a little bit messed up because signature is going to be for this entire body. Presumably not this split up message. So the DKIM will fail, but that doesn't matter much because SPF passes. So with most DMARC setups, it's going to pass. Now, I will be honest here and say I don't have like a great understanding of SPF, DKIM, DMARC, and all the whole setup there and how exactly all the policies go. Mail has always been one of those beasts that I never want to deal with personally, so
I don't think anybody really does.
yeah,
I know I haven't wanted to.
Like, that's actually kind of a key thing with this, is mail is in a sense very centralized. It's not centralized in every sense. Like, it's not like everybody is using Outlook or Gmail or something. But there are a few very popular providers and very popular implementations. So this has a pretty big impact. So I've just been talking kind of about the core issue there, with just, this first bug that they found being that outbound server will pass through the new line dot carriage return new line. It'll send that through, and then these inbound servers can be problematic, but they found quite a few inbound servers that would accept and would misparse the message like this. So what they found was a GMX. GMX is an email provider. They say they've got like 20 million users, but GMX is kind of the first place they found this issue in. But GMX is used with, or as part of Lonos, I'm not sure exactly how that's said, as like a mail provider. So they found like there's probably some like 1.3 million domains that they could have spoofed messages as. And that's the key thing. What you're getting out of this is that ability to inject a new SMTP message that looks like it's coming from the authoritative origin. So they could spoof a message that'll pass the SPF check for all those outbound servers. They can kind of get in there as long as an inbound server was misparsing it. They do go further. They actually did find smuggling with Microsoft Exchange. So that's like, what's used for Outlook. And a lot of places use Exchange. One thing that they did find though was that Outlook, it didn't filter the same sequence again, so it could be sent out. But Outlook did support BDAT, which is just another way of sending data, where instead of saying like data and then having that end of data sequence, it would just say like there's 72 bytes in this data and provide it that way. So you couldn't actually do this sort of injection. However, that required that the inbound server that Outlook was sending the message to did support BDAT. So what they found was actually a lot of servers. They just have the note here. Lots of servers on the internet support this, which is saying that lots of these servers will interpret that the malformed end of data sequence and not support BDAT, including their own sec consultant or sec-consultant.com domain ended up being vulnerable to this. And so they kind of use the example here. Now they're able to spoof messages as like outlook.com or any of the domains that are using Outlook, although, they kind of, I think, hit on what could be the power of this with just sending an HTML-based email, making it seem like it is coming from like no reply at outlook.com or something, like, these sort of phishing emails. It's passing all the checks, so it looks very legitimate. Like there aren't, apart from probably looking at the URL that some of these actually go to, like there aren't really key giveaways. You're not going to be able to look at the headers and see like, oh, this is a spoofing email. It's not going to be caught very easily by most analysis tools that are just looking like, it's passing the SPF. It's passing the usual checks. The only check that I think that fails is DKIM, but I think as long as FPF is set up, then like this is still going to generally pass. Anyway, so they had that, just missing that first carriage return. They decided to look a little bit further and go for exotic end of data sequence and just see if any servers are kind of supporting that, where like, carriage return line feed and then a null byte being put in there, and see if anything misparses that with either a null byte before or after the period character. They also have like line feed, dot line feed, instead of having the carriage returns completely, and just some different malformations of it. And what they found was that a popular sequence that seemed to be accepted by a lot of servers was carriage return dot carriage return, which again, it's not necessarily too sensitive, so a lot of outbound servers are going past that through. And as it turns out, Cisco Secure Email and their Cisco Secure Email Gateway is what will parse this, and that is used by things like Amazon, PayPal, eBay. Cisco, of course, uses their own, the IRS.
Pretty much every target you'd want to fish with as an attacker.
Yeah, a lot of high-value targets are using that. They do talk more about like the SPF and the DKIM stuff, so if you want a few more details about it, you can get it out of this post. But ultimately, what this meant is they found they could spoof a lot of emails quite easily with this. It did depend on different, like the outbound and inbound servers having these issues, so like there were some restrictions. Some setups wouldn't be vulnerable, but they found a lot of setups just were vulnerable.
Yeah, I mean, you wouldn't think that something as simple as email would be this complicated to deal with in terms of all the data being passed across and standardizing how it's being parsed and all the implications of it. Like, you think of email and you're like, email's really easy. We've had it forever. It's a solved problem, but it's
email has
really not.
Always felt like a really poor system and a really fragile system. Like,
Yeah.
we've had to kind of hack on encryption to it with, like, the start TLS command that comes in there to be like, oh yeah, maybe we should actually have some encryption over this, or like do some of that. There are other things now too that are a little bit better, but it's a product
It
of its
has a lot of
age.
cruft that's been inherited. Yeah.
Yeah, like it is an old protocol. It's like you can't replace it. Like if anybody tried to replace email today with something else, it would people would just freak out. It wouldn't get the adoption it needs. So we're kind of stuck with it. So there has just been a lot of just making it work. But I thought it was I think it's really cool research. I appreciate the idea there. Like, and it is like when you think about it, it makes sense. To go if you could do this with HTTP. SMTP is another thing that gets parsed by multiple servers. You could probably find some issues here, and in fact, they did indeed find some issues there. It's a bit different from the HTTP request smuggling, but also fundamentally very similar in, the idea of a parser mismatch or a parser desync, where the two things are parsing it differently. It's bound to happen when you have all these different implementations of what should be the same thing. It's a really cool research, quite impactful, cool to see. I'm sure they were pretty excited to see like an email coming in that seems legitimate from like admin at Outlook or something like that. Like that must have been a good feeling to actually get this to land and actually see it land on something like Outlook. Like a
That'd be a good
major.
chuckle. Yeah.
Yeah. Like it seems
Um
like they had some fun with it because like they have a lot of these screenshots like from admin at WebD or CEO at SecConsult.com. Like it feels like they had a little bit of fun with some of these. Like I imagine they had some other messages sent that we don't see here.
for sure. Just kind of relating back to that history part of it where, a lot of the like code debt and whatever has been inherited. One thing I found myself wondering when I was reading through this and looking at the diagrams they had provided is why is the from and to in both the commands and in the message data? Is there like maybe this is a dumb question, but that just seems like setting up for failure,
There's
like
kind of a
duplicating the
history
data
on
like that?
that. And I
Okay.
can't give you all of the history on that, but part of it is because of the authentication happens during that first one. So when you want to send your mail, you're going to send it from user. Let me just share kind of exactly what I'm looking at with you. So I've got this image up. The first one, that first mail from, so I am going to be clear, this is as I understand it, and I may be incorrect about this. I am no expert on SMTP. But that first, actually, I brought you kind of to a bad example here. But when you first connect to your outbound SMTP server, you're also going to have like your auth part of this in the command section. And that is before you actually send any of the message data. You don't send that message data. So this is so kind of the server knows who you're trying to send an email as. And then because of history, it still needs to be in that lower part too. They can't just force it. Although many servers will kind of force it by being if these two don't match, like if you try and send a message to somebody else, just doesn't send it or it corrects it or something. But basically the message data needs it because that's for history. But then it's been added into the first part for, I believe it's for authentication reasons.
The post does talk about that a little bit. Yeah. It just seems to me like why wouldn't you take the authenticated information and stick that into the message data instead of allowing that to be arbitrarily controlled completely?
Like
I figured there
that's
was probably some historical reason, but it's just like all this stuff wouldn't be as much of an issue if the authenticated data was taken as the authority instead of taking the you know user controlled data as the authority.
I think if the protocol were designed today with security in mind, you just wouldn't have that duplication. But because of
Yeah.
kind of just how things grew onto it and through it, you kind of see that duplication. So yeah, that's my understanding is that one is kind of a command that's used as part of the authentication, like so you know who it's being sent as and where it's going to. The other thing is I think there are cases where you will authenticate as one user and you'll maybe use the first mail from as one user but then actually send as a different email, so like aliases for example. Like for example, actually I don't know for sure what the SMTP looks like, but with our day zero domain, my login, I believe, is, formally actually my name at day 0sec, but I'll often send emails. If I'm sending an email or replying to something, I'm probably using Z at day 0sec. And so my authentication aspect of that's probably going to look like the Z at, or sorry, the, like my name at day 0sec. And then the from is going to be different using Z at day 0sec or whatever email I actually want to have seen by the other party. Um,
That's
so
fair.
there
Yeah,
could be
I
some
kind of
use
forgot about
cases.
aliased emails. That's probably the big reason that this was done.
Yeah, like I'm not sure about that because, like, again, it kind of feels like there are other ways to do that, but yeah, I mean, I think that would be a kind of legitimate use case for that sort of issue. But yeah, the duplication of the information, just accepting it, like blindly trusting it and letting it be in there, it's just an example. Like today, if somebody were designing a system, it would just not be so blindly trusted. Like they would get the authentication info from somewhere else rather than just having it be sent in there like as part of the data. But back then, nobody was really thinking about security. It's just, of course, this is the mail. It's from this. It's to this. Like whatever. We're just sending it.
Yeah, for sure. Definitely, like, I know that it's part of just sign of the times. Like, security wasn't really thought about or kept in mind as much back then. But I was wondering if there was more of a legitimate reason for it too, beyond just not thinking securely. And things like aliases do kind of explain that a little bit. So the two of them together, I can kind of see, you know, how it cooked into this, I guess.
Yeah, at least if my understanding of it is correct. I'll be honest, I'm not like 100% confident on that, but yeah, I mean, tying it back together now, there was some questions when it came to disclosure. So actually, I should also mention, since we were talking about the history, part of the thing with like the history is back then there were also, the non-compliant agents that are maybe using new lines of carriage returns, like not doing that full carriage return new line thing. And it seems like reading, I think Postfix did a message here about this, or have a post. Let me bring it up quickly. I think they put the blame on SendMail. Yeah, this vulnerability was introduced many decades ago in SendMail by allowing the non-standard line feed line ending in addition to the standard carriage return in line feed. So they kind of put the blame here on SendMail's behavior of kind of adopting that or allowing that in the past, and then because things are expecting that, other providers just kind of need to support it also.
That's always like such a pitfall that I find, even outside of like email, just in stuff that I'm maintaining. As soon as you start allowing things that others don't and people start relying on it, it's just like, oh no, we're gonna inherit this problem forever now. And it seems like that's what happened. That's what
Yeah,
happened
that
here.
that seems to be the case here. Now, I didn't look into it to see if it actually was SendMail who like started this, but seems fairly believable, at least that something way back in the day just decided to support that, and it kind of stuck and became a necessity. Kind of the problem here is they did this whole disclosure. They found this issue in like June of 2023. I'm just trying to see their dates here. Actually, I think they have a timeline at the bottom. Yeah, they found this in June, early June, discovered the issue with Exchange Online early June, and Cisco a bit later. Contacted Microsoft Research Center, Cisco, GMX, all at the end of July. And it turns out Cisco decided this is a feature, not a bug. And then they ended up needing to contact CERT to do their coordinated disclosure. So, if you're unaware, CERT is kind of like your emergency is it computer emergency response team? I forget what the C stands for now. Either way, you can work with CERT if you have a vendor who is denying that a bug exists. You can sometimes do the disclosure through CERT, like through your local CERT. I say local, but I think it's usually like country based or somewhat regional. But through CERT, and they will help facilitate kind of the discussion and try and get things going there when there is what's believed to be a legitimate vulnerability. Yeah, Cisco kind of rejected it. Anyway, so they end up going through with CERT, all of this, and Postfix was never informed about this issue before they disclosed it. So one of like the biggest mail server implementations didn't know until the holidays when CCC kind of came about, and it's like, oh, hey, there's this bug that impacts us. So I definitely feel for them, being
Yeah, it's
that
like a
this is
double whammy.
disclosed
It got dropped on them and during the
on the
holidays. Like
yeah
that
on the
sucks.
holidays has to suck. Plus it getting dropped and being left out. It seems like the issue, at least Sec Consulting kind of put it behind. They believe that when working through CERT, that CERT also kind of got in contact with other vendors, and other vendors were involved there. And so they believe that the other vendors who would have been impacted were kind of in the loop because of that. It turns out they weren't, but that's kind of where they seem to be putting more of the blame through. Is just like they either wrongly assessed the postfix not being vulnerable, or they had some incorrect assumption going on there, and postfix never found out. So I completely feel for postfix and not finding out having this dropped on them, because that does suck, especially over the holidays. I don't agree with people saying that like this should never be disclosed, or calling for the talk to be dropped from CCC. One, I mean, CCC is not dropping a talk like this. CCC is definitely a bit more on the controversial side of things. And I mean, Sec Consultants might have chosen to withdraw. And that would be fair. That would be within their, right to choose to do so. But like, CCC does not feel like the type of conference that would shy away from dropping O days.
I don't think they're gonna bow to pressure on things like that. Yeah.
But the pressure, I mean, given like CCC's history, like they don't have that, squeaky clean history of, some conferences out there. Like CCC was very much a hacking group in like the 80s and 90s. Like they
It's not like some commercial industry conference. No.
Yeah, like I
Um,
mean, I'm sure there is some of that, given the years that they've been around now, like they don't have that same reputation, but as a conference, I just don't think it's no go for them to have O days dropped.
but
Nonetheless,
regardless, it's just a really unfortunate series of events. Like there wasn't really malicious intent here, as
yeah,
far as I can tell.
yeah, like I don't think Sec Consultant were trying to like, oh, we're going to pull one over on postfix and not let them know. Like I don't think that was their
Yeah,
intent. They seem to
that
have
would
a
be
pretty
very
clear,
unreasonable as a
yeah,
take.
they seem to have like as a company, their responsible disclosure policy seem to have a bit of that. So like it seems like they generally tried and this just slipped through. It sucks. Like absolutely.
But it happens. I mean,
It does. There's a lot of vendors to keep in mind. It's surprising because like Postfix is a very big, well-known vendor that's going to be involved here. And it feels like just either way, they ended up going through this other process that kind of led to that led to some vendors being informed that weren't directly informed by them, so they were perhaps a bit out of the loop on exactly who was involved, and so they would have just assumed, of course, postfix and them would have been included, whereas they weren't. That seems to be the case for me. That's how I'm understanding this. So at least postfix was able to get something, but yeah, the timing really sucks for them. Like I feel for that so hard. Like to have this sort of bug just come up during the holidays.
kind of brings down your holidays. Yeah.
Yeah. That's kind of a
But
downside of the
nonetheless,
timing for CCC.
yep. I mean, just another point of evidence of why, like, I don't think they'll ever do it, but I really wish CCC would get moved. It's just
So
so
do I.
inconvenient, like as a time. But
It's a
that's
terrible
how it
time to
is.
travel. But
Yeah,
yeah, I think we've had this discussion before. Like every time we talk about
almost certainly.
CCC.
Yeah,
Um it's unfortunate. It's cool research. I appreciate what they put out here. I haven't seen their talk or haven't watched the talk, but the post is pretty easy to follow. Probably a lot easier to follow than my attempts to talk through it. Just having some of the visuals to help you get through there. But effectively, this is parts are differential on SMTP. So cool research. Potentially not the last, sort of attack of this style that we'll see, but just given how request smuggling went, but I guess we'll see.
yeah.
People aren't deploying really custom SMTP servers as often as they are deploying custom HTTP servers.
Yeah,
So
it's just not something people want to deal with. So in that way, it's probably a saving grace, and it's probably not going to be as widespread as like HTTP request smuggling is. But I mean, when you start talking about like mail analysis tools though, and middleware and whatnot, maybe. But yeah,
there,
probably not to the same
there
degree.
might be other sort of bugs. Maybe not the spoofing and like this exact smuggling sort of thing. There might be other things you could do when it comes to trying to attack the those middleman servers actually that
Yeah.
I haven't heard of a lot of research on.
Yeah. But yeah, like you said, whenever it comes to these smuggling issues, the diagrams and stuff are really helpful. And it is a cool attack. Some people might look at the impact and just be like, oh, it allows spoofing. Oh, big deal, phishing, whatever. But, like, especially when you're talking about email and being able to spoof domains like this, it is pretty significant. Like, a lot of monetary damages that are done is through, like, phishing and spear phishing and things like that. And this attack does enable that to be more effective. So it's definitely not something that should be like dismissed out of hand just because it's spoofing. Like the context matters a lot here.
Believable
So
spoofing messages can get like almost anybody, especially
oh
something
yeah.
like this. Like imagine if the spoofed message came through like, "Hey, somebody changed your password. Was this you?" And it came from it seemed to come from the legitimate email. The checks pass on it. There's a reasonable chance that you might click the button saying like, "No, this wasn't me." I think it's Facebook that does that, where like an account thing changed and they have the link for you to say like, "No, this wasn't me," or "It was." Probably some others do it too. I don't necessarily look that deeply, but I could absolutely understand somebody clicking that link when everything looks legitimate, us falling for this sort of phishing thing where it's just very well done because of this sort of attack.
So that's all the topics that we have for this episode. We do have a shout out in the form of a Trail of Bits post. Z spotted this one. It's in the area of CodeQL, which Z likes to talk about on the podcast every now and again. So I'll let him talk about it here quickly, and then we'll wrap it up.
Yeah, well, I haven't talked about CodeQL yet this year, so I'm getting it in now.
Ah, it's been a whole year. Yeah.
Yeah, but yeah, so this one Trail of Bits put out a post here catching OpenSSL misuse using CodeQL, and what it's about is using CodeQL to look for API misuse, specifically with OpenSSL. They have a somewhat tricky API to use. You could have some issues with it, and in particular, I think they're looking for like basically not filling up the entirety of a key buffer or whatever. I don't actually care too much about what they're trying to get through here, more just the idea of the API misuse. I think this is something that some bug bounty hunters could kind of lean on because a lot of queries I see right now are for these very generic bugs. Like, I'm going to catch all of these SQL injection bugs by, writing the whole analysis flow and seeing if anything flows into like the query, and you get your really massive query that way. Whereas this is kind of a bug that it's not going to get adopted into like CodeQL standard library or standard set of queries. But this is the sort of thing that, as somebody who's looking for issues, you can be like, hey, I've seen some applications do this or use this library in a weird way. And their example here is a C library, but this does support JavaScript, Python, Ruby, plenty of languages that you have other libraries in that could be misused. And so just querying for like, hey, they're misusing this and using, in this case, providing a key size that's, or maybe it wasn't size. I forget exactly what this thing queried for. Sorry. But I think that idea is kind of important. It's just like looking for a API misuse and querying for that, because that is something that's going to be unique to you as doing your bug bounty hunting. You can run this query against like all of GitHub basically, maybe not quite all of it, but you can get some pretty wide coverage with CodeQL with GitHub support for CodeQL. And so it's just something to keep in mind for, if you find those library misuses, think about writing a query for it. You might be able to get some extra bounties out of it. Or not. I mean, a lot of open source projects don't have much of a bounty, but it is something. And also, I think over the break, Trail of Bits did actually release their own kind of library of queries. That is definitely worth checking out. They've got a ton of queries in there.
I mean, this sort of use case just perfectly slots in for CodeQL. when you're looking at like library misuse type issues, it's really annoying to look for manually because you have to look at the code that's invoking the API and then reference the API documentation, try to look for discrepancies or things that might have been missed. And it's just like querying and doing that with automation is just way more feasible. So it's a perfect use case for CodeQL. It makes a lot of sense,
Yeah, and
especially in like crypto libraries and things like that, where it's so easy to misuse the API and have critical issues because of it.
and I think it's another way of kind of formalizing your knowledge. When you've dug into a library and you've learned about these ways that it could be misused, oftentimes if you don't find it again very soon, like you just forget about it and you never really think about, maybe it's in your notes file somewhere, like, oh yeah, there was this thing I did this one time. Whereas writing the query kind of puts it into a more accessible way that you can now reuse against other targets or whatever. But it just kind of formalizes your knowledge, your own research, and leaves you with something kind of tangible after the fact. So that's also something I kind of like with CodeQL. You could, at least some types of queries you could do with semgrep too. I'm not sure about this one in particular. Yeah, like I said, I mean, this one I wasn't so interested in like what they were actually doing in the actual query versus just the idea of querying for the API misuse. But
Those are some great
nonetheless, it
points.
gets a shout out.
All right, and with that, that's all the topics we have for this week. So thanks everyone who tuned in. Previous episodes can be found on YouTube, Spotify, Apple Podcasts, and more links on Anchor. Our Discord and Twitter links are down below in the description and on our website, day0sec.com, which is also where we have vulnerability summaries and such. With that said, we'll see you on the next episode.